Welcome to this in-depth tutorial on using Apache Kafka with Java. In today's video, we will cover everything from setting up Kafka, producing and consuming messages, to advanced topics like error handling and scaling your applications. Let's start by briefly understanding what Apache Kafka is. Kafka is a distributed streaming platform that can be used for building real-time data pipelines and streaming applications. It's designed to handle high throughput and fault tolerance, making it a popular choice for microservices architectures. To get started with Kafka, we need to have it installed and running on our local machine. You can download Kafka from the official Apache Kafka website. Make sure you also have Java installed on your machine, as Kafka is built on top of Java. Once you have downloaded Kafka, unzip the package and navigate to the Kafka directory. Here you'll find several scripts in the get-bin folder for managing the Kafka server and the Zookeeper service. Kafka requires Zookeeper to manage distributed brokers. To start Zookeeper, use the following command. This command runs the Zookeeper server. You should see some logs indicating that Zookeeper is up and running. Once Zookeeper is running, we can start the Kafka broker with the following command. Now that our Kafka broker is up and running, let's create a topic. A topic is essentially a category where records are published. Use this command to create a topic called My First Topic. You should see a success message after running the command. This means our topic has been created successfully. Now, we'll write a simple Java application to produce messages to this topic. First, let's set up our Maven project. Make sure you have Maven installed on your machine. Create a new directory for your project and navigate into it. Use the following command to generate a new Maven project. Once the project is generated, navigate to the project directory. Now, open the pom.xml file, and we need to add the Kafka client dependency. Now we can create the producer class. Here's a simple producer example that sends messages to the My First Topic. Create a new Java class named Kafka Producer Example. In this example, we set the necessary properties for the Kafka producer. We serialize both the key and value as strings and then use a for loop to send 10 messages to our topic. We also provide a callback to output metadata info for each sent message. Next, let's build and run our producer application. Use this command to build the project. Now we can run the application. Make sure you are in the target directory where the JR file is located and execute the following command. You should see output in your console indicating that messages were sent successfully. Now, let's consume these messages using another Java application. Just like before, let's create a new class for our consumer. Create a Java class named Kafka Consumer Example. In this consumer example, we set up the properties required for the consumer, subscribe to our topic, and start polling for new messages. Inside the polling loop, we output the consumed records to the console. Next, let's build our consumer project and run it. Make sure you're in the project directory and use the same Maven commands as before. Run the consumer application using the following command. You should see the consumed messages from the topic displayed in your console. Now you have a basic understanding of how to set up topic producers and consumers using Kafka with Java. Next, let's discuss how to handle potential errors that might occur during the message production and consumption processes. Error handling is crucial for building robust applications. For the producer, errors can occur when sending messages, such as network issues or timeout exceptions. You can handle exceptions in your callback function as shown earlier. To improve this further, consider using message retries by adjusting properties like retries, AX, and linger.ms. For consumers, ensure that you handle deserialization errors gracefully. If the consumer encounters a message it cannot deserialize, it may throw an exception that could be caught to perform logging or provide fallback options. Another important aspect of Kafka is message offsets. By default, Kafka retains messages for a configurable duration, and you can leverage offset management for this. You can store offsets in a dedicated topic, or use Kafka's built-in features for offset management. While consuming messages, you can commit offsets manually or automatically, depending on your application's requirements. Now, let's go over how to scale our Kafka application. Kafka can be scaled horizontally by adding more brokers to your cluster and partitioning your topics. When creating topics, you can specify the number of partitions, allowing multiple consumers to read messages in parallel. Adding partitions increases throughput, but may require careful consideration of key assignments. Different keys can result in messages being distributed across different partitions. In addition to partitioning, you can adjust your producer and consumer configurations, such as increasing the batch.size and linger.ms to optimize performance for high-throughput scenarios. When it comes to production workloads, it's also essential to monitor your Kafka clusters using tools like Kafka Manager and third-party solutions. This ensures you're aware of consumer lags and broker health. Now that we've covered scaling and error handling, let's briefly look at persistence and retention policies. Kafka is designed to store messages for a specific retention period, but you can configure topics to retain data indefinitely or based on size, ensuring you don't run out of storage. You can adjust these settings in your topic configuration. Here's an example of how to modify retention settings for our topic. In this command, we are setting the retention period to 1 week. As our final stretch, let's touch on Kafka Streams, an API provided by Kafka for stream processing. Kafka Streams allows developers to write applications that can transform and analyze streams of data in real time. To use Kafka Streams, you'll need to add an additional dependency. Here's what to add to your pom.xml. Let's create a simple Kafka Streams application that reads from one topic, processes data, and writes it to another topic. Create a new class called Kafka Streams Example. In this example, we create a Kafka Streams application that reads from my first topic, transforms the message values to uppercase, and writes them to my output topic. We can also run this as we did with the producer and consumer. Build the project, package it, and then run it to see real-time data transformations in action. In conclusion, we have covered a lot today. From setting up Kafka, creating producers and consumers, to error handling, scaling, and even streaming. Remember to explore Kafka documentation for more advanced features and best practices. Thank you for watching. If you found this tutorial helpful, please like, share, and subscribe to my channel for more Java programming content. Until next time, happy coding!